All right, guys, we're getting ready to start our next job here in the shop, and what we have is this stainless steel impeller, and this belongs to a viewer of mine named Jeff. He had contacted me and sent me a picture of this and said that this is an impeller that they use for their pumps, and this one accidentally got dropped, and I've got it marked right here with the two black marks showing where it dropped and where it actually hit it. So this being the seal ring here, it actually bent this, so it's got it thrown out of, out of balance, and now it's not. You don't have a true seal surface there anymore as well. But anyway, Jeff sent me some pictures of this and showed it to me, asking me would this be something that I would be interested in possibly fixing for them, so that they don't have to just absolutely scrap it. He already replaced it. This is a replaceable part that they buy. And he says if I'm able to fix this, then he would love to be able to put it on the part shelf and has it as a backup spare instead of just scrapping it and just being out the complete cost of these, because these are pretty expensive to buy. So I told him, yes, I would like to see about getting it fixed for him, so send it on, and that's what we're going to do. So my plan of attack is we're going to go over to the welding positioner, and we'll use our TIG welder. And we're going to come in here and we're just going to build this up. We're just going to make some passes through this whole area. That's why I kind of marked in here about where it needs to start and stop. And we'll build this up. I think one row of beads through here, maybe two right along the edge, should be enough, and we'll get this thing built up. And then we'll go to the lathe, and what we're going to have to do is machine a mandrel for this to fit on. And that's what this material right here is. This an old piece of shaft stock that I've salvaged it and used it a couple times for something else. But what we'll do is we'll chuck this in the 4-jaw chuck in the Monarch, and then we will machine this in here so that it has a really, really close fit on this bore. Hopefully where I can take it and just kind of twist it up on there so it has no clearance over the shaft. So it's got a nice true fit on the bore. All right, it'll come out this side. We'll have some threads machined on there, and we'll use this 3/4 tin flange nut to pull it up tight onto the mandrel. All right, so that's what we'll do for the lathe mandrel right there. Now I've got this mandrel here as well. This is one of the oldies that belonged to my dad. We can use this mandrel here to hold it in the welding positioner. This end's already 7/8. That's what our bore is a standard 7/8 bore. All right, and then this one goes down there like that, and you can just tighten it up with your hand. But you see, you have no way to reach in there really to tighten it up. But we will just use this one in the welding positioner, chuck it right there, and use the positioner to go in there and rotate it and put a nice bead across there and fill this up, and then we'll go to the lathe and turn it. Once we're in the lathe, we'll probably touch this bottom area up here too, trim it just a little bit, kind of bring the radius back in there the way it should be. The final step, he asked me if I would go ahead and turn this OD down to 5.5 inches. So we're going to turn that down. Right now it's 7 inches, so we need to take 1.5 inches off the OD. So apparently he's going to want to, if this works out, he wants to have it as a spare for maybe a different size pump that he's got in there. All right, so let's go ahead and go get our welder set up and start doing our TIG welding there. Before I get started doing the welding, I want to go ahead and swap out this flow meter. This is the flow meter that actually came with the Everlast. I have the Everlast Power TIG 200 DV, and this was the stock flow meter. I haven't trusted this thing ever since I got it. I just don't know if it's accurate. So I went ahead and I've got a different flow meter I want to install, and I'll show you that here in just a second. I'm going to go ahead and start taking this guy off. And I was told by several people whenever I got this and hooked it up to not rely on these, go ahead and swap these things out. So that's what I have done. And actually we are going to a dual flow meter system for this thing here. So I'll actually have 2 argon lines, because what I plan on doing is hooking up an argon argon line over to my heat treating oven. So we'll have a dual flow meter here. One's feeding the machine, and then one will be available to run the heat treating oven whenever it's needed as well. So let's go over there and I'll show you the new one that we're going to use here. So this is the new dual argon flow meter right here. This is Spark brand. So I had reached out to Jody Collier, a weldmonger, and asked him what he offered as far as the dual flow meters, and this is what he carries now over on his website, weldmonger.com. Great guy to know, awesome friend, and he carries a lot of really good product for the welding industry over on his website, so be sure to check him out. So this is the unit right here. So that's just it. We'll just have, you know, the ability to have two lines connected to this thing at all times. So there's the fitting with the barb. These will screw onto there. Got another one in here. That's it. So we'll go get it installed now. Looks like I need to turn my bottle, actually turn it 90 degrees so that the gauge will be facing that way. All right, we went ahead and just turned it 90 degrees, and go ahead and get the bar fittings here snugged up in there. Get our gas line tightened up on the barb fitting here. This plastic hook that you see right behind it, this guy right here, this is the hell hook. That's something else that's over there on Jody's website as well. It's just a nice little helpful tool. Goes right on the bottles here. You can hang your aprons, your welding hoods, your welding caps, whatever you want on there. Works out pretty nice. All right, so let's go ahead and let's give it a try. Turn the machine on. Seems to be working pretty good. That sounds a lot better than what that original one does. Yeah, it seems to be working good. All right, we've got the impeller set up here in the positioner. I've got the variable speed foot pedal, so I'll be utilizing the variable speed for the rotational speed that I need right there. I'm gonna be running, this is the 308L filler rods that we're going to be using. This is a 304 stainless steel impeller, and I think we are ready to go. I did a couple little tests there. I've got it set at 65 amp right now, and I'll adjust it if I need to, you know, bump it up a little bit. And we got our new armrest right here. That should make this a little bit easier now when we're using our positioner. I want to take a look at this and see how it's doing. That's looking pretty good. We'll keep her going. I'm trying not to run it too hot and cause it to start falling through the other side there. All right, that's looking pretty good right about there. That should be a good start stop. I'll have to hit that edge right on the corner and build that corner up just a little bit more. But we're making progress. Go ahead and back it up. Here's a little tighter shot of the build up there that we just did. I'm not through yet. I need to go ahead and get this front corner. I'm afraid if I do it in this position right here, it's going to try to undercut a little bit more. So what I'm going to go ahead and do is rotate or flip the welding position up in a 90-degree position, and we'll just weld it up on the top. Do a flat weld on that edge right there. We've got it sitting in a really nice position there. I think that I can get in here and just easily fill that corner in, just like it's just where it's at right there. Probably won't even rotate it. Probably just going around by hand. There's the other side. Something about like that right there. That looks pretty good. I think that's going to work right there. Be able to face that out. Clean corner up. All right, here's you a little better look at the impeller. It's cooled down nicely. So a little bit tighter shot of the buildup that we did. It didn't turn out too bad. So hopefully that's going to clean up good. But during the turning process, if it looks like that we're not going to, like some of these edges are low right on each side. I think I built it up plenty there, but if it ends up being low there, we'll just go back to the positioner and add a little bit more weld in there. So get it turned, faced off, and hopefully that's going to turn out good there. And then of course we got to turn our OD down to 5.5 inches also. So we'll go on down to the Monarch lathe. We'll get this piece chucked up and go ahead and machine our mandrel to hold this piece. We'll start getting our impeller fixture machined. I'm going to use a telescoping gauge and a mic, and we'll measure the bore. Nominal size is 7/8, but I want to go ahead and turn our fit so that we're very close. I want it to be a slip fit, but sort of a very, very close slip fit. So it looks like we got that at, we're measuring it about 876.5 according to this measurement here. 876 and 5/10. Do it one more time. Always do it at least twice to verify it. When you do this, try not to look at your mic. Don't worry about what it's saying. Just look at your fit right here. And you want to get the touch, get the feel right. Get it to where it just touches as it's going through there, interference. So 876 and 5. So same measurement. 876.5 is what this is. So we'll shoot for that and try to make it maybe a couple tenths under that. So it'll be, we want it to where it'll kind of, you know, wiggle and slide up on there. And then once we get it turned, we'll have it threaded so that we can use, this is a 3/4 10 flange nut. We'll have it where it pulls it up there against the shoulder. Okay. So we're down to about 45 thousandths to bring it to size. So this is a 25 thousandths pass, and we're running max speed on the Monarch, 700 RPM. And as I've said before, when you're trying to hit your finished size, once you get down to, you know, like within 50 thousandths, just try to split it equally between two cuts. And you do it right, it usually lands right on what you want it to land on. So after this cut here, I'll measure it, and I'll try to finish it out to 0.877, and then I can file it, emery it to the fit that we want for the impeller. And then after this last cut, I'll go ahead and face that shoulder, so we got a good clean square shoulder there. Shaft is not hot at all. Go ahead and get a measurement with our mic and see where we're at. So we're at 901. All right, so that'd be 25 minus 1, so 24. So we're looking at 24 thousandths to bring it to 0.877 is what we want right there. Okay. Go ahead and dial in 24 on the dial here. That's 10, 24. And what I'll do, since this is going to be an undercut for threads, what I can do is stop it right here. Just back off and verify it. Now you can't always do this, but when you've got to turn the shaft down on the end, you can go ahead and stop it and check it. And if you're undersized, this is a quick way to correct it. So we are at 877 and a half. So that'll work right there. A good mill smooth file will bring that right to size within just a few strokes on there. It'll clean it up. And notice I pulled the coolant back just a little bit. It's helping to keep it from slinging off of the workpiece and the chuck as we get closer to it. Just enough to keep that carbide nice and cool. Come into our shoulder. I got a dial indicator over here. I'm going in 10 thousandths. There we go. Good clean face cut there. So now we'll set a 0 here, and then we're going to turn it down to a 3/4, do an undercut there, thread relief, and then single point thread it. Let's get our undercut in there. And go 130 thousandths. That's our double depth of our 10 pitch thread. I love using the radius tool for this. Makes a nice strong joint there, plus it looks nice too. And just come in until that corner blends together. Just like that. Come back to this side right here and then widen it out just a little bit, and then just back it out with the compound. All right, now we'll just put a chamfer here and here. We'll be ready to thread. All right, our threading tool we're going to use is our Tetra Mini Cut. This is a 4-cornered stand-up style of insert that I've been using, and so far it has been working excellent. I haven't had any issues with it. Okay, we're touched off. We got a 0 on the cross slide. We're using compound end feed here. Let's just make a scratch pass and test it. Got our pitch gauge set to the 10 pitch leaf there, because we're cutting a standard 3/4 10. That is right.
All right, we finally got that fit that we like, that machinist fit on the thread. Okay, the only thing left is we need to go ahead and get our fit filed and polished down to size. Just giving it a check again. We don't have much, so we use a nice mill smooth file to do that. Just very gently give it a few licks and then go ahead and mic it, because as soon as you hit it, you're taking some high spots off the tool marks there, and you may take it down. Yes, I mean we're pretty close right there. I'm gonna go ahead and hit it a couple more licks. Right there. Just get the dust off of it. Let me grab the impeller and we'll check it. Pretty close. We got to get it down a little bit more. I just do that to get the dust off of it, the filings off of it. This is going to be a close fit right here. And it is not wanting to go. I got an idea. I think what I need to do, come on. I need to check that keyway and make sure there's not a burr in there on that keyway that's causing it from going on there. So let me check that and we'll keep continuing with our fit. Okay, after some filing, we've finally got her to fit good, and I got to use just a little bit of lubricant on there. I'm putting some of this knocker loose on there, just a little bit, because it did try to gall on me one time. And anytime you're fitting like this, if you're fitting and it gets stuck, just spray a little lubricant on there and it'll usually work itself loose. There we go, just like that. See, we got a good fit. And I'm going to go ahead and put a drop on the threads here too. I'm not going to tighten this up yet. I just want to see how it looks like it's going to run. That's pretty crazy. That seal ring is not machine true with the bore. It is not machine true. It may not fix it, what we're doing there. Huh. Let me keep scratching my head about this to see what we're going to do here. All right, so let me run it for you this way so you can see what I'm talking about. It looks like that the step that's machined back there against the face is true. This looks like it's true, but this is not. That is running out. It's not because of the bend. I don't think it was machine true. I just don't think it's warped that bad. It looks like it's just not machine true. So I'm thinking what we're going to end up having to do to get this repaired correctly is we can go ahead and turn this and turn it down, and what we can do is take it about, go ahead and get it turned down to where it's round. We'll measure this wall thickness there, and we'll go ahead and take about half of it, machine that down about half thickness, and then we'll have to get a piece of stainless tubing and machine a sleeve and heat shrink a sleeve on there, and then machine the sleeve back to size. I think that's going to be about the only way that we can fix that right there. One of the proper ways to fix it. I don't know if I need to spray that with the buildup. But anyway, I'll bring you guys back when I decide what I'm going to do here.